that type of example. So to find the convolution of a discrete time signals like h of n, or write a question. Find the response. Find the response of discrete time LTI system having an impulse response, having impulse response h of n is equal to a to the power n u of n, and input applied to the system is x of n is equal to a to the power n un. Means same input is applied to the system. Then find what is the response. To find the response, you cannot apply here the simple tabular form that you can use for the finite duration sequence. So you have to go through the conventional approach to find the response of the system. To find the response of the system, y of n, suppose let output y of n is equal to x of n convolution with h of n, and this convolution is extended or expressed as the sum of the infinite terms of x k h n minus k. This is the approach to find the response of the system yn. Now here in this case h of k will be a to the power k u of k, and x of k will become a to the power k u of k. Similarly, you have to do h of n minus k. So represent here h n minus k, it will become a to the power n minus k and u of n minus k. These two terms you have to put in the given formula. What will become y of n? It will be summation k is equal to from minus infinity to plus infinity a to the power k u of k, a to the power n minus k u of n minus k. So now you can rearrange all these terms. It will become k to the power summation from minus infinity to plus infinity a to the power n, and a to the power plus k minus k will become cancelled out. It means a to the power n will be constant, and a to the power k and a to the power minus k u of k u of n minus k. This will be 1, and it will be simplified as k is equal to from minus infinity to plus infinity u of k u of n minus k. Now you have to put the value of uk and un minus k. Basically u of k is what? It is step signal, and u of n minus k, it is also a step signal, but a time shifting is present in this case. So this value, amplitude, magnitude, whatever you can say, the value will be 1, but it can change the range of this summation, the limit of the summation. What will be the limit of this summation? You can find. Now this question, one thing is important, that is the value or the limit of k, so that or you can say the range of the summation. That's why a simple thing you have to find only this range of summation. To find the range of summation, you can plot a graph of u of k and u of n minus k and see what is the range of summation. Take this is x-axis as k and u of k will become a discrete step signal, discrete time unit step signal like this up to infinite 0, 1, 2, 3, 4 and so on. And u of n minus k, here time shifting as well as time reversal you have to do. So if you shift the time, means k and u n minus k, it will become, and plus k here, because time shifting is done, so it will shift the value of impulse or value of samples present in the UK, isn't it? So it will be somewhere in the minus n, here it will start from here like this. From minus n to minus n minus 1, minus n minus 2, origin 1, 2, 3 and so on. And now take the time reversal, u of n minus k, it will be the mirror image of this u and plus k. Here time reversal means mirror image of y-axis. So somewhere in the positive value of it will be limiting value, the origin, this range, two samples are present, and this is minus 1, this is minus 2. In this direction it will be up to minus infinity. Now this u of k and u n minus k, the magnitude will be always 1, magnitude will be always 1, but if you multiply this u of k and u of n plus, if you multiply this uk and u n minus k, you can see here from minus infinity up to 0 and from minus infinity up to 0 it will become 0, and in the range of 0 to n, and here 0 to somewhere n, suppose here in this case it will be non-zero value, and after n to infinity, here n to infinity, again it will be 0. So this value will become 1 and the range of summation will become 0 to n, and the value is 1. So you can now add this 1 n plus 1 time from 0 to n. So u of y of n will become sum of k equal to 0 to n 1. Now this 1 can be added n times, but Here 0 is also present. So the total sample will be n plus 1. A to the power n, this will become n plus 1. Here is example, you can see 1 plus 1 plus 1 plus 1 up to n plus 1th position. So the total value will be 1 added up to n plus 1th position. So the total sum will be n plus 1. This value is defined in the range of n greater than equal to 0. Y of n will become this for n greater than equal to 0, and this is your output of the system. So in this way, or there is another way of writing the same expression as a to the power n into n plus 1 into u of n. So either way you can write the same expression. This is the final response of the system. Now if I give the another example, suppose h of n, suppose another example, h of n is equal to a to the power n u of n, and x of n is equal to b to the power n u of. This is the impulse response and input to the system. Find the response of LTI system. So response y of n will be h of n convolution with x of n. And now again the same process follow and try to find the value, what will be the result. X of k, h and minus k, again put the same value and try to find the expression. I am writing the result, but you go through the proper methodology that we have discussed in this example, previous example, and the result will be a to the power n plus 1 minus b to the power n plus 1 divided by a minus b u of n. This will be the result. Please do. Now some property of the convolution you should know, that identity property of convolution. It says f of t convolve with delta t, the result will be f of t itself. Means any function taken the convolution with this delta function, the result will be same function. Convolution of impulse function with any function gives the same function is signal. This is one of the very important property. You can prove this property also. A very simple proof. Another extending this property only if there is time shift in ft as well as delta t, then what will be the effect of this? See, if f of t minus t1 convolution is taken with delta t minus t2, it will result f of t minus t1 minus t2 in this way. Now there is another question. Now suppose delta t is taken with the convolution of delta t itself. What will be the result? Please think. Tell me the answer. It will be delta t itself. Another property of this convolution, in this case you can say the differentiation property. Differentiation if y of t is equal to convolution of ht and xt, then derivative of yt will be convolution of xt with the derivative of ht, or derivative of ht convolution with xt, or equal to h of t convolution with derivative of h of t. Any one of the signal, either ht or ht, can be differentiated and convert with another signal, will give you the result of derivative of this quality. So this is also very important. You can use this property to find some other questions like to do some example. Find the response of LTI system having an impulse response of ht is equal to ut, and the question, find the convolution of ut and u of t. Means two signal, two same signal yt and yt are convolved. That is, h of t is equal to ut, x of t is equal to ut, then y of t is equal to h of t convolution with x of t, or u of t convolution with u of t. Same approach you can follow here also. Y of t will become integration from minus infinity to t, u of tau. What is the formula? It is integration from minus infinity to t, h tau x t minus tau d tau. Like that way only, u of tau, u of t minus tau d tau. This can be written in this way. So if you now again you try to simplify this expression, u of tau and u of t minus tau, you will see the magnitude is always 1, but it will change the limit of integration. And what will be the change? can see by plotting the graph of u of t. See, this is u of tau, here tau, magnitude is 1. Now if you shift by t amount of time, if you shift this for delay, it will become like this. It is minus t. This expression will be u of t plus tau. Now time reversal operation is performed on this graph. It will be mirror image above vertical axis. So it will be u of t minus tau. Here it will be t origin and the magnitude. So now if you multiply these two, u of tau and u of these units, this will multiply, it will be from minus infinity up to 0, and from minus infinity up to 0, this is result is 0, and from result is t, after t will also same 0. So the total result will be only in the range of 0 to t, and this is 1, this is eta. If you again simplify, it will be t. So in this case, you can see here two step signal are convolved, the result is t. Or simplify, in this similar expression can be written also here t greater than or equal to 0 is condition given. That is ramp signal. So if you convolve the two unit step signal, it will be a kind of a ramp signal. Same expression can be, same question can be also solved by using the derivative property. Suppose method 2, y of t is equal to u of t convolution with u of t. Now take the differentiation. Take the differentiation of yt. What will be y of dy dt divided by dt is equal to derivative of ut convolution with ut. Now you know that this y of t, keep it as it is. Derivative of u of t will be delta t. Derivative of ut delta t convolution with u of t. Now one property that I have described, that convolution of u of any function is delta t. The result will be that function only. Now take integration both sides. So d of yt will become integration of u of t dt, and here y of t will be integration of ut, as you know it is rt. So here in this way, by using the differentiation property and the property of impulse, unitary property or identity property, that can be used to find the convolution in a simple way. Or you can say here also, see this, if take another example, let's say find the convolution of f of t with u of t. See, y of t will become f of t convolution with u of t. So now take the derivative of y. What will be the effect of taking this derivative? It will be reflect in any of the function ft or ut. It's this derivative of any of the two functions. So you know the derivative of ut is delta t. Derivative of ut is delta t. So it can be easier to write the derivative of this function with respect to derivative of ft. That's why take the derivative in this expression. Now here d of ut dt will become f of t convolution with delta t, and convolution of these two, because ft convolved with any delta function, result will be ft xi. So here y of t can be written as integration of f of t dt. See what is this effect of taking the convolution of ut. See, it is integration of the function. Now you can make a note that if convolution of any function or any signal with unit step signal gives the integration of the. So in simple way we can write f of t convolution with u of t will be equal to integration from 0 to t, integration from 0 to t f of t dt. This is one important. One another was describing earlier. We see that convolution of the ft with delta t is like this. So these are the some standard note result you can always keep in your mind. So do we have more time? One last topic of this unit 1 is called correlation. Correlation of signal. Correlation basically stands for the closeness or the similarity. Similarity, closeness, same type of behavior. So considering consider two signals f of t and g of t. Then correlation is a kind of function. Correlation function is a measure of amount of similarity between GT and HT. Similarity between FT and GT. It is defined as written as GRFG like this way, and tau is the amount of shift parameter. In this way, correlation function is defined as integration from minus infinity to plus infinity f of t g of t minus tau g dt. And if you have to measure the amount of similarity with a different function, the term is called cross correlation function. Cross correlation function. If two same function with the shift parameter tau, this is calculated a function like f of t minus tau dt. This is called autocorrelation. Same function, correlation with the same function. Autocorrelation. So this is the very simple technique. Some formula is somewhat looking similar with the convolution here also. So you can also find this autocorrelation by using the convolution technique. How to find this convolution technique is applicable? How does this convolution technique applicable? See, f of t and g of t taken as the two function, and the convolution of these two f and g is calculated, and after that put the value of t is equal to minus 2. Like this way you can also find the autocorrelation. Similar way here, convolution of f of t as well as with f of t itself is calculated. Put the value of t is equal to minus 10. So it will give you the same result with this that you can calculate it from this integration. So these are the basic formula is applicable where you calculate the correlation function. Now if you see some example how to find the correlation of any signal. Take the example of f of t is defined as a rectangular gate signal 0 to 1, amplitude is 1. Find the autocorrelation function. Rf of tau will be equal to integration from minus infinity to minus infinity to plus infinity f of t minus tau t tau, where f of tau, you see f of t is defined as the gate pulse from 0 to t having magnitude 1. So if you shift, you can also plot f of t minus tau. What will be the graph of f of t minus tau? It will be some delayed function. It is some delayed like this. Here tau is 1 plus tau like this. Now if you multiply these two functions f of t and f of t minus tau, you can solve this integration. Value magnitude of these two functions will be same, 1 multiply 1, it will be 1, but it will change limit type of integration. See, these two graph will be non-zero value when you multiply these two functions only in the range where, see, where this tau belongs to 0 to 1. Means this tau value will come in the range of this 0 as well as 1, and also from this, means if you overlap these two functions somewhat like this. Now let me change the color, like this type of, in this range only non-zero value. So here it will be tau, it will be 1 plus tau. Now this tau can be varied from minus infinity to plus infinity. Now vary the value of tau from minus infinity to plus infinity and check the overlapping part of this. From this to this, take the integration, take the integration of overlapping overlapping. So in this way you have to find the convolution, correlation of the function. And if you calculate, you will see it will be like convolution itself only the two function, it will find a triangular pulse. Two rectangular will give you a kind of triangular result. This will be RF of tau minus 1 plus 1. Try to simplify and plot. If you plot the graph of RF of tau, you will see like this type of graph. And in this graph you can observe here R f of tau is even function. Always this will be a even function. Means similarity or the similar waveform is present in this first quadrant and second quadrant. So this is very important property of R f of tau. Another important property is R f of tau value at 0 will be always greater than or equal to any other value of tau. That is RF of 0 is maximum value. RF of 0 is maximum value. This These are the two three important property of this. Or one other property you can also define R at of infinity. This will be equal to, or approximately it will be 0. This will tend to 0. Means at infinity tau, if the value of tau we put infinity, that will be the minimum value approximately 0. So these are the some property of autocorrelation function, and same all these properties also similar for cross correlation also. And okay, I think some more property are have to describe, and some more example we should do on this topic. We will discuss later. Today we should stop here. From here we will discuss in the next class. Thank you for today's class. I think your unit 1 is almost complete. You can now get the quiz. So in this week only we will schedule quiz for unit 1. So prepare for the quiz. Okay. Thank you for the class. Thank you.
Thank you, sir.
Thank you, sir.